The next one, electric motor. You know how it works? Do you have
Not,
any idea how it
not
works?
sure, sir.
Okay, now I am demonstrating the principle. This is very simple. The previous one, it is used here, right?
Yes, sir.
Yeah, this is the arrangement. So you can see this arrangement. This is the zoomed figure. You can see this one.
Yes, sir.
This is the highly zoomed. That's the only thing. Here, this is the cross section of this rod. This one.
Yes,
This
sir.
indicates cross section of this one. So this figure is highly zoomed cross sectional diagram of this left hand side figure, right?
Yes, sir.
This is just a cross section. Okay. So what is there? Shall I flip the magnet?
Yes, sir.
Okay. What happened?
It changed.
Okay. In which way?
It's going the opposite direction, the object.
First of all, what exactly happened to that rod?
That
Here it
rod is
is.
moving, sir.
Yes, moving. Exactly correct.
It's
Why it
moving
is?
outwards and inwards when you're changing it.
Yes, movement is in two directions, right?
Yes, sir.
Inwards and outwards. When it is inwards, when it is outwards. So these are the observations you can make, right?
Yes, sir.
Okay. So why it is moving or which is needed? If some object is moving means something should be there. What exactly that something is? There must be some force. We know very well, right?
Yes, sir.
Okay. What is the force? What type of force it is?
Magnetic force.
How you can say that it is
Sir,
magnetic?
because there's a magnet here.
Very simple,
Yes, sir.
right? So because we are placing some magnet and in between that magnet we are putting some rod, right?
Yes.
Okay,
sir.
what should be the nature of this rod? What type of rod should I consider? This should be a
Conductor?
magnet, conducting, magnetic or non-magnetic or non-conducting?
Magnetic, sir. Magnetic.
Okay. So all magnetic materials are conductors?
No, sir. Few may not be.
May not be. You take the natural existing magnets, they are almost like non-conductors, right?
Yes, sir.
Okay, there are few, but there are conductors also. So some of the conductors are magnetic, some of the conductors are non-magnetic. Suppose you take copper, is it magnetic?
No, sir.
It is not, but it really opposes the magnet. This
Yes,
is called a diamagnetic. There are three or four segments in magnetic fields also, but that we don't go into that much detail right now. Okay, anyhow, so magnetic force is existing. Suppose if I remove the current, because this is connected to current, isn't it? You can see.
Yes, sir.
If I remove the current, does this rod still moves?
No, sir.
What is your guess?
No, sir. I don't think so.
Why? Why?
Sir, because the rod is supported by two other rods which are moving it.
No, it is resting on it. That's it.
Sir, not sure, sir.
Suppose this is a magnetic material, that rod, okay?
Yes,
It is kept in between the two magnetic poles. Definitely it should touch either of the poles.
Yes, sir.
What do you think? Is it simply resting on these two horizontal cylinders or the support rods? What do you think? or is it floating in air? What do you
I
guess?
think it's just rested, sir, by support rods.
If it is a magnetic material, still can it rest? What
Yes,
should be
sir.
the direction of that motion of that rod if current is not there? It should be moving either upwards or downwards, isn't it?
Yes, sir.
Because poles are vertically aligned, isn't it? Not the horizontally.
Yes, sir.
So, but here, if I remove the current, even suppose if current is removed, suppose in that case also that rod is moving. In which direction there is a chance of movement? Is it possible in the horizontal direction?
No, sir.
No, definitely it is not. So horizontal force is not due to the magnetic field, right?
Yes, sir.
Okay, now what is your guess, is correct or not?
Yes, sir.
Is it correct?
No,
Whatever you,
sir.
no, it's not, but partially correct.
Yes, sir.
How? Why I said partially?
Not sure, sir.
Not sure.
I didn't get it.
Right. So if it is a magnet or magnetic material, definitely if I want to move it, what type of force I need to use? Magnetic force. So it is moving means there should be magnetic force, right? But
Yes, sir.
it is different from the magnetic force that is produced by the already present magnet, right?
Yes, sir.
Right. This is the way you have to have the questioning and then analyze the data or the information, right? Okay, anyhow, this is not that much easy, but just you watch it out. So this arrangement, some current is flowing, there is a magnet, I am keeping this rod, it should be conducting as well as it should be conducting only, may not be
Magnetic, sir?
no need. Why? Because we already demonstrated one point. If I have a conductor, if some current is flowing through that conductor, it will be gets converted into a magnet.
Yes, sir. Understood.
You got it point how that magnetic
Yes,
field
sir.
is there? Okay, it may not be a magnet, right? But why it is moving? Not because of electric field, because of magnetic field, because magnetic field only interacts with the magnetic field. Can it interact with electric field?
No, sir.
No, it can't. Can mechanical force interact with electrical force? No.
No, sir.
So like this you can analyze, because how you can estimate that magnetic force should be existing, we already demonstrated one point. If I have a current carrying conductor and a magnet, current carrying conductor, unless and until there is a magnetic field around that conductor, there is no possibility of force, right?
Yes,
Am
sir.
correct?
Yes, sir.
Yes, that you should remember. Okay, that's very crucial point. You remember this point always whenever we are dealing with what is the topic actually? Magnetic effect
effects.
of electric
Electric
field.
current.
Exactly, you can watch that one here, right?
Yes, sir.
So I am getting some force because of electric current. If there is no current, there is no force. There is no movement or motion of the rod, isn't it?
Yes, sir.
So what actually these supporting? These are not the simple supporting. They are the actually electrodes. This wire, or I can say the rod, is resting on these two electrodes. Means this is one electrode, this is one electrode. Two ends of that rod is connected to the current source or battery,
Yes,
I can
sir.
say. Then only there is a possibility of current to flow through that wire or rod, right?
Yes, sir.
Okay, it is in the form of a rod, but actually that is a wire, straight wire. I can
Yes,
use
sir.
spiral wire also, can't I?
Yes, sir. We can.
We can use, because that spiral wire also produces magnetic field if current is passed through it. I can use rectangular shaped wire also, can't I?
Yes, sir, you can.
We can use, right? So it may be of any shape, but here I am considering a cylindrical shaped current carrying conductor. So when current is passing through it, if it is under some magnet, then what is the effect? There is some force which is pushing the wire or rod, whatever we call it, right?
Yes, sir.
Okay, is it clear now?
Yes, sir.
When do there is a force? If a current carrying conductor is placed inside a magnetic field, right?
Yes, sir.
Okay, that will be clarified further. The same principle is used in the working of motor, right?
Yes, sir.
Okay, now you can see what is the shape of that wire I am considering now.
Squarish shape.
Okay, square, or in general I call it as rectangle, right?
Rectangle. Yes,
Two
sir.
ends of this one are connected to battery, right?
Yes, sir.
Okay, now this is the direction of magnetic field. This is the direction of current. This is the direction of force. And shall I run it?
Yes, sir.
Okay. So what is the direction of force now?
It's in anti-clockwise.
No, you observe carefully. How many forces are acting? One or two?
Two, sir.
Two are acting. How they are? Opposite to one
Okay.
another.
Yes.
Are they acting at single point?
No, sir.
They are acting at
Many points.
two different points. Exactly. Diagonal points, I can say, as per the diagram, right?
Yes, sir.
As per the diagram, these are called the diagonal points. Am I correct?
Yes, sir.
So if two forces are acting at two diagonal points with the same magnitude, then what is that called? That is called pair. Okay.
Yes, sir.
That is also known as torque, which is responsible for rotation of any object.
Okay, sir.
Unfortunately, that term is not there in the mechanics part. Is it there?
Yeah. No, sir.
Rotation is not there for you, unfortunately, but you have to just remember as it is for now.
Yes,
Okay,
sir.
you just remember two and equal forces. If two and equal forces are acting at the same point, what is the resultant force? Got my point?
Yes, sir.
If two equal and opposite forces acting at the same point, just I draw now. What is the resultant force?
Sir, it will be stationary, sir.
What is the resultant force? How much it will be? Will it be zero or non-zero?
Non-zero.
Two equal opposite.
No, sir. Non-zero, zero.
Two equal
Zero.
opposite acting at the same point, right?
Zero, sir.
Okay, now I am drawing the another one. Okay, these are equal, opposite, but acting at two different points. What is the resultant force? Will it be zero or non-zero?
Zero.
Zero?
Yes, sir. Zero.
How?
There is 2 points, sir.
Okay, this is one point. This is another point, right?
Yes, sir.
This is like one rod. Okay. Take, for example, you take one a stick, right? Of 1 feet or 2 feet length, right?
Yes, sir.
Do you have any such sticks?
Oh, yes.
If you have, take one such stick, 1 feet or 2 feet, right?
Yes, sir.
At one end you apply or you try to pull upwards at one end. At other end you try to pull downwards. Will it be at stationary or will it move? That stick.
It will move, sir.
In which direction it will move?
One part will move up, one part will move down, sir.
Means it gets rotated, isn't it?
Yes, sir.
Then you said no force, 0. So it's not 0.
Not 0, sir.
It is non-zero. This is very important point, right?
Yes.
So always you should remember that very important, but most of the students will do mistake here. Equal and opposite forces, they think that resultant is always 0. Not. You must careful at which point two different points are the forces are acting at the same point. This diagram, if I have drawn like this, definitely this will be at stationary, right?
Yes, sir.
So I need how many now? 1, 2, 3, and 4 forces, right?
Yes, sir.
This diagram leads to 0 force once again, because here equal, opposite, same point, equal, opposite, same point, right?
Yes, sir.
So you remember this one. This is called a torque. Equal opposite forces acting at two diagonal points. Diagonal points also very important, right?
Yes, sir.
This one, diagonal points, or I can say end points, right?
Yes, sir.
So diagonal points. Now you look at this. These are the diagonal points, equal and opposite acting. That is the reason why this wire gets rotated, right?
Yes, sir.
This is like the stick. So how it is behaving? This circular wire is behaving like a stick, isn't it?
Yes, sir.
So stick experiencing one torque. One torque means two forces equal, opposite, but acting at two
Different point.
different points. Different means diagonal points. You should remember. Non-diagonal points never work.
Yes, sir.
It won't get rotated. For diagonal, force will be there even for non-diagonal, but that motion won't be a circular one, right?
Yes, sir.
Okay, so the point here is it is getting rotated. So the behavior of the circular wire is not like rectangular wire is not like a rectangular one. It is behaving like single stick, or I can say single magnet, right?
Yes, sir.
Can I use that word? Because magnet will be having two ends, right?
Yes, sir.
One end is experiencing downward force, another end is experiencing upward force. So that stick or the bar magnet gets rotated within the magnet, right?
Yes, sir.
Okay, so what are the requirements? This is one magnet, right? On the left hand side, are you able to see it?
Yes, sir.
This one, right?
Yes, sir.
So this is one magnet. This is the second magnet. So I need two magnets first. They should be of same strength, right?
Yes, sir.
Okay, next point is I need this circular or rectangular wire, not circular, rectangular wire I am considering. Two ends are connected to battery, right?
Yes, sir.
So this arrangement is called electric motor. So what is the principle? The principle is very simple. The principle is that the current that is passing through the electric conductor in the rectangular shape is getting converted into magnetic field. This magnetic field interacts with the magnetic field produced by two permanent magnets,
Yes,
right?
sir.
Okay, so that interaction is producing what type of force? Electrical, magnetic, or which force? What is the resultant force?
Magnetic.
What is the nature of resultant force? Hello?
Magnetic, sir.
Sure?
Yes, sir.
How? Just carefully watch it.
Yes,
This current
yes, sir.
is passing through that rectangular wire. This is producing magnetic field, right?
Yes, sir.
This magnetic field interacts with The magnetic field produced by the two permanent magnets, or I can say magnetic poles, right?
Yes, sir.
This interaction is leading to another force.
Mechanical.
Okay, now you got the point.
Yes,
Mechanical, because rotation of the object comes under mechanical force, right?
sir. Yes, sir.
Okay, now you got the point. So what is the result? Electrical force is converted into mechanical force or mechanical force. So electrical force gets converted into mechanical force with the help of magnetic force, right?
Yes, sir.
Okay, this principle is involved. Electrical field is there, magnetic field is also there. But what is this electric field is doing? It is not directly interacting with the magnetic field, but we are making use of that current carrying conductor in the form of a rectangle. When that current is passing through that rectangular wire, there is a magnetic field. That magnetic field is interacting with the already existing magnetic field. This interaction is producing rotation of the wire, right?
Yes, sir.
Okay, this is the principle of electric motor. Every day we are using lots of fans in our homes, right? ACs,
Yes.
fans, everywhere you look around, everywhere we can see so many different types of motors. Almost all are using the same principle, right?
Yes, sir.
Whatever may be the electrical fan or electric motor and everything, they come under this category. But there are two categories. One is called DC motor, another is called AC motor.
Yes,
There is a
sir.
slight difference between those two, right? But
Yes,
that is not there for you. But if time permits, definitely I explain you the difference between AC and DC motors, right?
Yes,
Okay,
sir.
so shall I stop now because this is
Yes.
almost 6, because okay, tomorrow I will be completing this chapter also. Maybe
Yes,
if I'm out of station tomorrow, I will inform you, or I may be of other work, I will inform you tomorrow. Otherwise, as schedule, we can continue the class, right?
yes, sir.
Okay.
Yes, sir.
So most probably I will be taking the session because I will be finishing it, and then we move on to the remaining topics. Okay.
Yes, sir.
So you remember up to this point, this is just an extension only. Just I show you the other possibilities, because what is the effect of number of turns in that particular rectangular shape and everything. It's only an extension of the previous one. And this is more like a, good activity, and there will be worksheet for this one. That
Yes.
worksheet will be given anyhow. Okay, you received any worksheets? Sir told that he will be sending you.
I did not get any, sir, yet.
And okay, so definitely today I persuade and then and sit before and then I myself send otherwise, right?
Yes, sir.
Okay, so I am stopping the screen share, and then shall I take leave now?
Yes, sir. Thank you, sir.
Okay, thank you and take care, and then bye.